This is your class number 6 of module number 4, and in this class we are going to solve one problem on this roller type of a follower. And one more thing is, you can observe this type of a cam and follower. So there is no dwell at all. There is a negligible dwell between the outstroke and the return stroke. It means the follower is moving in upward direction and in a downward direction, and in between there is a negligible dwell. It means the follower is not going to take any rest between the outstroke and the return stroke. Okay, so based on this kind of a cam and follower, and I'm going to solve one problem, that is nothing but problem number 4. Okay, so first I'll read out this problem. A roller follower is offset to the left by 1.2 centimeters, or can say as a 12 mm. Both are correct. A roller follower is offset to the left by 1.2 centimeter, and it is clearly given that the type of follower is offset follower. Okay, so whatever you are seeing this in this image, it is a radial, but I have taken this as an example to explain the kind of follower motion. Okay, do not connect this as a do not take this as an offset follower. This is an example of radial follower. Only just observe the type of follower motion it has. In the problem, it is given a roller follower is offset to the left by 1.2 centimeter, and the basical radius of the cam is 3 centimeter. So the capital R is given, that is a basical radius as a 3 centimeter. Just remember this. And the desired displacement of the follower along y-axis for different cam rotation, that is theta, it is given in this table. So you can observe this table for different rotation of the cam from 0 to 30, 30 to 60, up to 330, and can consider as 360 also, last one. It will be 0 mm. It means for different cam rotation from 0 to 360, what is the displacement, the distance traveled by the follower for different cam rotation. So you can see along the y-axis you have to take the follower displacement, that is a 0.25 centimeter, then 0.9 to 1.87. So you can see there is a gradual increase in the height. So this distance is nothing but the vertical distance that is covered by this follower. So you can consider any one point as a reference. You can take the midpoint or the center of this roller as a reference, and it will travel through some distance. Okay, from 0 mm to 0.25, 0.9 to 1.87. The similar manner. So you can see for the first 0 degrees there is no displacement, 0. For the next 30 degree of this cam rotation, so it is covering a vertical distance of 0.25, and for the next again 30 degree, that is up to 60. From 0 to 60, it is covering the total distance of 0.92 centimeter. Similarly, you can see as the cam starts rotating from 0 to 360, the follower is rising and it is coming down. So where it is coming down, you can see there is an increase in the distance, that is 0.25, 0.92, 1.87, 2.83, 3.5, 3.75. Can observe at this point exactly it is covering the maximum distance, that is 3.75. That is at 180 degree. So this problem is very much easy. There is a slight difference in the given data. Okay, I was explaining this one. You can see it is covering from 0 to 3.75, the maximum distance that is traveled by the follower. After this, it is coming down. There is no rest. Immediately for the next, you can say for next 30 degree, it is coming down. That is 3.5, 2.83, 1.87, 0.92, 0.25, and finally it will be 0. For the 360 angle, it will be again 0. You can see all the dimensions are exactly symmetric. When you consider this as a midpoint, it means the maximum distance that is covered by the follower, 3.75. So you can take, you can observe the dimensions are symmetric. Here also 3.5, 3.5, 2.83, 2.83. It means the type of follower motion is rising, returning, rising and returning. There is no dwell at all. Remember that. It means for the first 180, from 0 to 180, so the follower is rising and it is reaching the maximum displacement, that is 3.75. And for the next 180, that is 180 to 360, it is coming down 3.5, 2.83, 1.87, 0.92, 0.25. Finally, it will become 0. Yeah. So this is the given data, and since already the displacement and the angles are given, there is no need to draw the displacement diagram because already the data is given. So directly you can draw the cam profile. And for the roller having a radius of 1 centimeter, and one more data is the radius of this roller is 1 centimeter. And one more thing is the cam rotates in the clockwise direction. This is also very important. And one more, the slight change in this problem is the follower is offset towards your left. Okay, do not worry that this radial or the offset follower, just observe only the type of follower motion. Okay, so there is no dwell at all. It is rising, it is returning, rising, returning. So there is a negligible dwell in between the outstroke and the return stroke. And if it is clear, I'll go with the given data. So again, I'll write down the data. That is for, I'll copy the same data from the problem. That is for 0 degree, the distance is 0. For the 30 degree of cam rotation, the distance travel is 0.25. Same thing I'll copy 0.25, 0.92, 1.87. And the last one is not given. It means it is understood that it will come down to 0 mm. The initial point. It has started from 0 mm. From this point, it is reaching 3.75 at 180. Again, it will come down up to 0 mm for complete 360. And I can consider these as the distance traveled by the follower for different angles. I'll write down these distances as 1 to 1 dash, 2 to 2 dash, 3 to 3 dash, 4 to 5 dash, 4 dash, 5 to 5 dash, 6 to 6 dash. This is the outstroke. Okay, this is the outstroke, and it will come down. It means the distance will reduce from 3.75 to 3.5, 2.83. So these are nothing but the distances, the vertical distances. I can indicate as a 5 to 5 dash, 4 to 4 dash in the reverse order up to 1 to 1 dash. So you can imagine the displacement diagram which we have drawn for the previous problem. So instead of drawing the displacement diagram, already the data is given. There is no need to draw once again because at each and every position, I know the distance travel, that is 0.25 for 30. For the next 30, it is 0.92. Okay, so there is no requirement of the displacement diagram. So I can consider these distances only as a 1 to 1 dash, 2 to 2 dash, up to this 1 to 1 dash. Only this much change when you compare with the previous problem. And if it is clear, I'll directly go to the one more given data. And first I'll write down the type of follower is a roller follower. It is already given in the problem, and it is offset to the left. I'll write this also. The roller follower is offset towards left. Yeah. And after that, what about the stroke length? In the problem, they are not mentioned any the stroke length. Stroke length is nothing but the maximum distance that is traveled by the follower. So you can see it is 3.75. So this is the stroke length. So I can consider the stroke length, that is the maximum distance that is traveled by the follower, is 3.75 centimeters. If you want, you can convert into millimeter also. And the base circle radius, that is capital R, is given 3 centimeters. So it is nothing but the minimum radius or the base circle radius. It is given in the problem. And the roller radius I'll take as a small letter r. It is also given in the problem. It is given the roller radius as 1 centimeter. And you have to draw the cam profile for the offset type such that the follower will be towards your left by 1.2 centimeter. Okay, I'll explain while solving the cam profile. It means the follower is slightly shifted towards your left such that the axis of the follower will come approximately here and the axis of the cam will be here. They will be separated by a distance 1.2 centimeter, and the follower will be shifted towards left. Okay. And one more thing is, as I said, whenever the kind of follower is a roller follower, there is one more radius or the circle will come. That is nothing but the prime circle. This comes only in picture when the kind of follower is of a roller type. As I said in the previous problem, The prime circle radius is equal to, it is the summation of the base circle radius, that is a 3 centimeter, plus the roller radius, that is 1 centimeter. 3 plus 1, that is 4 centimeter. Please remember all these points, that is the stroke is 3.75, base circle is 3 centimeter, prime circle is 4 centimeter, and you need to draw the offset circle because the type of follower is the offset follower. The distance is 1.2 centimeter, which is given in the problem. That's why I'm to consider the one more circle, that is offset circle. And these are the 4 angles. So I'll write down these 4 angles from the given data. So which is nothing but, you can see here, from 0 to 180, it is a rising. The distance is increasing. After this point, that is after reaching 3.75, for the next 180, it is coming down without taking rest. Without taking rest, for the next 30, it is coming down 3.5. For the next 30 degree, it is becoming 2.83. It means, so 180 is the outstroke angle of the cam, and again for the next 180, it is a return stroke. There is no dwell in between the outstroke and return stroke. So I can consider theta naught, that is outstroke angle is 180, and the first dwell angle is 0, and the return stroke angle is 180, and the second dwell angle is 0. So you can see I have taken these both the dwell angles as 0 because the follower is not going to take a rest between the outstroke and the return stroke. Only these 2 angles are important. So I hope.
Sir.
Yeah.
Sir, where will be the prime circle?
So prime circle is the reference circle with respect to which we are going to draw the cam profile. So approximately it will be at the center of this roller and the center of the cam. It will be like this.
Okay, sir.
Okay. And I have given the detailed nomenclature of this cam and follower in my notes, in the written notes. Please read that also. After that, if you face any problems, I'll clarify in the next class. Okay. And
okay, sir.
Okay. And I'll start with the cam profile. Directly, I need to draw the cam profile for offset follower, not for the radial. So these are the steps I have mentioned here. You can go through these after the class, and I'll follow the same steps. Okay, and after that you'll get this kind of a cam profile. So this is exactly what I want. And this is the center of the circle, and this will be the offset circle, and this will be the base circle, and this will be the prime circle. And on this prime circle only, I'll take the reference lines and I'll transfer the distances 1 to 1 dash, 2 to 2 dash, 3 to 3 dash, up to 6 to 6 dash, similar to the previous problem. And I need this black color one, the dark line, the dark curve, which is nothing but the cam profile, the outer surface of the cam. I need to design this one. I want this solution. I'll explain this one. That is a cam profile for when the follower axis is offset with respect to the cam axis towards left. You can see the follower is towards your left. It is shifted towards your left. And I'll solve the problem. First, I'll indicate the center point. After that, I'll draw the base circle. So this is the first step. For every problem, you need to draw the base circle, so which is given as a 3 centimeter, or you can take it as a 30 mm. Both are correct. So after drawing the base circle with a radius of 3 centimeter, I'll indicate the axis of this circle or axis of the cam. Okay. So these are the imaginary circles: the base circle, the offset circle, the prime circle. They are imaginary lines with respect to which we are going to draw the cam profile. Ultimate thing is, I want the outer surface of the cam, not these base circles and all. These are the reference circles. So after indicating the vertical axis, which is passing through the center of this circle, I'll indicate the prime circle, which comes into picture when the type of follower is a roller type. So this prime circle will not come in a knife edge follower. It will not come in a flat face follower. Only this comes into picture when the type of follower is a roller type. Just remember that. So already I know the prime circle radius is 4 centimeter, which is nothing but the summation of a base circle radius. It is a 3 plus the roller radius, 1 centimeter. Total is 4. And since I'm drawing the cam profile for offset follower, I need one more circle, that is offset circle. Since I want the offset between the follower axis and the cam axis by 1.2 centimeter or 12 mm. So I'll draw the circle, and the radius of this offset circle will be 1.2 centimeter or 12 mm. 1.2 centimeter. Just take the radius as 1.2 centimeter because I want a gap between a follower axis here and the cam axis. Since it is towards left, it is mentioned in the problem. I want offset towards my left. I'll draw this follower axis towards my left. In the previous problems, I have taken the axis of a follower towards my right because it was mentioned in the problem the type of follower was offset towards right. That is the only difference. And after drawing all these circles, I need to draw a tangent to this offset circle at this point. Otherwise, I'll extend this follower axis only. Before that, I'll draw one horizontal line like this towards my left. So it will intersect the offset circle at this point. If you want, you can zoom this area so that it will be clear. Please zoom this area so that it will be clear. So I have drawn this horizontal line towards left so that at this point I can draw the tangent line. So this is the tangent, or it is the axis of the follower. This is the axis of the follower and this is the axis of the cam. Both are separated by 1.2 centimeter or 12 mm. And you can see this axis of the follower, it will intersect the prime circle. As I mentioned, the reference is prime circle. Just ignore this base circle. Always in the roller type of a follower, the reference circle will be prime circle. So this follower axis will intersect the prime circle, this red color one, at this point, and I'll indicate that point as A, similar to the previous problem. And I'll join both the points. Before that, I'll draw a circle because I need to indicate this roller follower, right? At this point, by taking the center as A, and I know the roller radius as 1 centimeter, I'll indicate the roller. It means I'll draw the circle, that is a pink color one, and I'll indicate this follower. This entire is nothing but a roller type of a follower, and you can take the height of this follower of any length. It is not mentioned, so you can take of any length. If you want, you can take the stroke length as the height of this follower. Okay, it is not compulsory to take 3.75 only. You can take of any length. Since I know the stroke length of the follower as a 3.75 centimeter, I'll take the height as 3.75. So I have indicated the base circle, then I have indicated the prime circle, then after that I have drawn this offset circle by 1.2 centimeter because I want the offset by 1.2 centimeter. And after that I have drawn the tangent to this offset circle, and this tangent is nothing but the axis of the follower. You can see. So this is the axis which is passing through the center of this follower. Okay, so this is the axis of the follower.
It is left side offset, sir.
Towards left because it is in the problem. It is given as a left.
Okay, sir.
If you want confirmation, yeah. So you can see in the first line itself, the roller follower is offset to the left by 1.2 centimeter. Say it is given. If it is right, you just take it towards your right. Then after
and rotating into clockwise or anti-clockwise?
In clockwise, it is given. So you can see in the last sentence, the cam rotates in the clockwise direction.
Okay, sir. Okay, sir.
Yeah. After doing this, I need to indicate all the angles. Before that, I'll join these 2 points. Center of the roller and the center of all these circles. That is O and A. So this is my.
So what is the radius, sir?
Which one? The blue color line?
Sir, that pink color dot, sir. Pink color circle. Now what is the radius, sir?
This is a roller radius, 1 centimeter. You can see the roller circle. So it is given in the problem.
Okay, sir.
It means this is the follower, right? This is the follower of roller type. The roller radius is 1 centimeter. Okay, yeah. And after that, I'll join these 2 points. That is the center of this roller which is having a radius of 1 centimeter and the center of all these circles. And this is my first reference line. So from this only I'll start indicating the angles. Okay, all the 4 angles. And before that I'll check what is the rotation of the cam. It is clockwise. It is clearly mentioned in the problem. That's why I'll indicate all the angles in a counterclockwise direction. It means opposite to this cam rotation, like this. And I'll keep the protractor on this OA line. Okay, it means the reference line or the 0 degree of the protractor has to be in line with this blue color line. It means because I want OA as a reference line, the initial point. And I'll indicate the 180 degree. First 180, there is no dwell at all. I'll directly go to the return stroke, that is 180. It covers total 360. It means only 2 angles because both the dwell angles are 0. Only the outstroke is 180, return stroke is 180, total 360. So this is outstroke, that is you can indicate as AOB. And I'll indicate the reference point on this prime circle only, all the alphabets. Angle AOB is nothing but the outstroke angle. So you can see, indicate the outstroke angle AOB in a counterclockwise direction with respect to this prime circle. And the one more angle is the return stroke because there is no dwell at all. BOC will be again 180. Yeah. So after indicating both the angles, so what is the next step? I need to divide this outstroke angle or the prime circle with respect to the outstroke angle into 6 equal parts. And what is the angle covered with respect to this prime circle? That is 180. That is AOB. Means I need to divide this prime circle between point A and point B, which covers 180, into 6 equal parts. How much it is? 180 by 6? 30 degree.
30 degree.
Correct. 30 degree each. Okay. Use the protractor, again mark the points on this prime circle only. Yeah, you can zoom in. Now you got all the dots. You can see the blue color dots, which are nothing but 30 degree with respect to the center of the circle. Using the protractor, I have indicated all these divisions on the prime circle. And since this is the type of offset follower, I will not draw the radial lines which are joining towards the center. If it is a radial follower, it means the axis of the follower and the axis of the cam are same. I will draw the radial lines and I'll extend. But this is a kind of offset follower, as I explained in the previous problems, all these those 3 problems. Since it is an offset follower, I need to draw tangent. I need to draw tangent from all these 6 points. Before that, I'll give the namings. So this is 0, 1, 2, 3, 4, 5, 6. These are the 6 divisions on the prime circle between A and B at outstroke angle or 90. So from all these points, I'll draw the tangents like this. I'll draw tangent to this offset circle. I'll draw one more tangent, tangent, tangent. Because you can see the follower axis is tangent to this offset circle. You can see here, it is tangent. That's why I'm going to draw tangent to this offset circle from point 1, point 2 up to point 6. You can see one by one if you want. This is the first tangent. Just zoom this area. You can see this blue color line. It is tangent to this offset circle. Just please zoom this area for your convenience. And from point 2 also I'll draw a tangent line to the offset circle. From point 3, from point 4, 5, 6. I got 6 tangent lines with respect to this offset circle. And what is the next step? Just extend these tangent lines. I'll call this as a tangent lines, not the radial lines. If they're intersecting or converging at center of the circle, I would have called them as a radial lines. Since they're tangent lines, so I'll call them as a tangent only, the tangent lines. I'll extend towards backward direction like this to some convenient distance, And after that, with respect to all these 6 points and these 6 radial lines, I have to transfer the distance, that is 1 to 1 dash, 2 to 2 dash, 3 to 3 dash, 4 to 4 dash, 5 to 5 dash, and 6 to 6 dash. Already it is given in the problem. So you can go through the problem statement again. So I have noted down. These are the distances for different angles. I have given the numbers 1 to 1 dash, 2 to 2 dash, 3 to 3 dash, up to 6 to 6 dash for the outstroke. Again, it is coming down because the distance is reducing. It is decreasing from 3.75 to 3.5, 2.83, again up to 0. I know these distances. It means 1 to 1 dash is 0.25 centimeter. Okay. Using the compass, I'll copy the distance, that is 0.25, with the help of scale and the compass, 0.25. I'll indicate this with respect to the prime circle, that is from 1 to 1 dash is 0.25 centimeter. I'll cut the arc from 2 to 2 dash. I'll copy the distance one by one for both outstroke and the return stroke. Yeah. So you have extended these points. I'll take the reference as this point 1. So I know the distance, I'll cut an arc. So what was the distance? It was 0.25 centimeter, right? First distance, yeah, it is 0.25. I'll copy that with the help of compass. Yeah, I'll take the reference as 1. I'll draw the arc, that is 0.25 centimeter. It'll get very small length. Okay, so it will intersect this first radial line, sorry, the first tangent line at this point. I'll indicate as 1 dash. Okay, this is 1 to 1 dash. Similarly, just draw the arcs by copying the distance 2 to 2 dash, 3 to 3 dash, 4 to 4 dash, 6 to 6 dash. It will be 3.75. So you'll get all the distances which you have transferred on these tangent lines from the given data. Okay, so this is 0.25 and up to this is maximum 3.75 centimeter. And after that, at these 6 points, that is 1 dash, 2 dash, 3 dash, 6 dash, you have to draw the circles by taking these points as a reference, the center of the circle. Just draw the circles. That is nothing but the roller. Just indicate the rollers by taking these centers. I'll explain once again. After extending all these tangent lines, I have transferred the distance from the given data 1 to 1 dash on these 6 tangent lines from 1 to 1 dash up to 6 to 6 dash. I'll denote those points as 1 dash, 2 dash, 3 dash up to 6 dash. And by taking these 6 points as a center, I'll indicate the roller. I know the roller radius is 1 centimeter. I'll draw the roller here, up to this. So you got all these rollers. And after that, I'll complete this also. After at a time, I'll draw the tangent to this all these circles, so that I'll get the camera file at a time. Now also you can draw, but instead of that, first I'll divide this return stroke also. Again, the return stroke is 180. You can see here, BOC. Again, I'll divide into 6 equal parts between B and O. Okay, so this area, I want 6 equal parts. Again, 180 by 6 to 30 degree each. So you can see I've indicated the reference point, the division points on the prime circle only, not the base circle. After that, I'll give the namings. Since it's a 6, it is not well at all. Again, it will come down. It means 5, 4, 3, 2, 1, 0, because there is no gap between outstroke and return stroke. It is a continuation. 0 to 180, 180 to 360. It means I'll give the common the 6 number. Okay, 0, 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1, 0. Again, from all these 6 lines, these 6 points with respect to the return stroke angle, draw the tangents. Draw the tangent. Just continue. So now you are at this point. Again, draw the tangent like this. So you can start from here also, or you can start from here also. Both are correct. Okay. So with respect to this drawing, I'll start from here. Both are correct. So I'll draw a tangent to this offset circle from this point 1. Just zoom this area so that you'll get. So this is the first tangent, the green color line. It is a tangent to this offset circle from point 1. Similarly, from point 2, just draw tangent to this offset circle. From point 3, 4, 5, again 6. Already the sixth line is there. After that, just extend these tangent lines, the green color tangent lines, in a backward direction. Yeah. Again, go back to the displacement, the data with respect to the displacement diagram. Yeah. So now you're at this point, 6 to 6 dash. It is already indicated. It is common. Again, just copy this 5 to 5 dash. It is again 3.5 only. Both are same.
2.83.
Correct. 5 to 5 dash is 3.5 centimeter. Just copy that. Just go to the cam profile. Just cut an arc. Similarly, just copy all these 5 distances, 3.5 to 0.25, one by one with the help of a compass. Yeah. So just take the reference as this 6 to 6 dash is already indicated, that is 3.5. Next, indicate 5 to 5 dash, 4 to 4 dash, 3 to 3 dash, 2 to 2 dash, 1 to 1 dash. Yeah. Now you'll get these intersection points between the arcs and these tangent lines. It is 5 dash, 4 dash, 3 to 3 dash, 2 dash, 1 dash. And again, just take the center as a 5 dash. Just draw one roller with a radius of 1 centimeter. With respect to the 4 dash as a center, draw one more roller up to this 1 dash. You can see the pink color lines are nothing but the roller with a radius of 1 centimeter by taking these 5 dash, 4 dash, 3 dash as the center. Now I completed all the angles, that is outstroke 180, return stroke 180. After getting all these rollers from this point, okay, this is the first circle, correct? Okay, I'll start from here. I'll draw tangent to all these circles. I'll draw a smooth curve and it has to be tangent to all these rollers. So better you can see here. Yeah. So this black color one, the dark curve. You can see it is tangent to all the rollers, starting from this first circle. So which is nothing but the cam profile for the given condition. Okay, for the given angle and for the given displacement and for the offset type of a follower. Okay, so this is the final solution of problem number 4. Yeah. If any doubt in this problem, you can ask. Otherwise, I'll wind up today's class. Okay, thank you.